Hello and welcome to the BobCAD-CAM V31 2D milling webinar today. This is a support and advantage plan member, so I want to thank each and every one of you for joining us here today. And today we're going to go over some 2D machining features. So a little housekeeping first. If you guys can use the question and answer, just let me know where you're from. If you can just type in as a question where you're from and what version of BobCAD you're running, that would be very helpful. I assume most of you guys are running the V31. That's why you're in here. Louisiana, we have Travis. Thank you so much, running V31. We got Virginia with Nicholas, V31. Iowa, Alan, V31. Larry, yeah, there we go. Bill in Texas. Tony in Indiana. Ben in Ohio. We got Robert from Melbourne. Very good. Ron from PA. Let's see here. Okay, we got Brian in here from California. Yep. Michael Arms. You know, it's okay if you guys don't have the V31. If you're just trying to get a jump start in some of the new features, that's completely fine. If you haven't downloaded the V31, I would definitely recommend it. Stefan from Germany, thank you so much. But this webinar is about the V31 and some of the new features that are in the software. Give me just a second here, guys. Give me just a second. I want to save this file. So the first tip that I'm going to give you guys is if you import a 3D model, like a SolidWorks file or a step file or something like that, it's a really good option to save that as a native file before you move forward. And again, I want to thank everybody for showing up here today. Okay. The second thing is this question has come up quite a bit as far as where are we hosting the webinars that we're doing. They're going to be hosted on the support page. This is the support page here. You can go to bobcadsupport.com and log in. If you don't have your login, you can email support and they'll send it to you. On the left side screen, there's a navigation. You can go to webinars. The list of our webinars as we record them will be uploaded here so you can view them later. Okay? All right, if there's any questions about that, just let me know. And again, if there's any questions, today's webinar's topic is about 2D machining. So any questions you have about 2D machining, go ahead and fire away. One of the questions that came in is how do you display your vise or your table, which you could do to use for simulation. So we'll get into that one a little bit later. The first thing that we want to talk about is, you import a file and, it's a solid model and it doesn't always come in the right orientation. That's the first thing that I want to start with. If you guys have ever opened up a 3D model and it didn't come in the right orientation, just say, yeah, that's me. Just comment that, yep, I've experienced that, okay? There's a number of different reasons why that happens. It really comes down to what design package the software was used. Like this one was done in SolidWorks, so it comes in the wrong orientation. As a general rule of thumb, what I like to do is I like to rotate that geometry to get it flat in the XY plane. Now, it's not a necessary step, but it is something that I do often. And yep, there's a bunch of people here. Like Larry says, always. Scott says, yes. Michael's like, always. Tony's like, never the right orientation, okay? So it comes up a lot. The part could be out in space or it could just be in the wrong orientation. Now, it's not necessary for you to move the part into the right orientation, but I definitely recommend it. It does make it easier. Now, a couple of hotkeys here. I know we talked about the user interface. I have Control 1 is set to a top view. Control 2 I have is set to a front view. And Control 3 I have set to a side view. Those three views are very useful. Control 1, Control 2, Control 3. And it will help me understand where that part geometry is. If you guys want to customize your shortcuts here, you can go to Customize Shortcuts from the File menu. And then here are all the listed commands. And then here are the current keys. I do recommend Control 1 for a top view, Control 2 for a front view, Control 3 for a side view. That's a really good idea. The other thing is your F commands, F1 through F12. you can set them up for your most common features that you guys use. All right, so a little tip there: F1 through F12, set up your common features. Control 1, Control 2, Control 3, top, front, side. Okay, I want to rotate this geometry. What do? I go to Utilities. Utilities is where you're going to find all your editing commands. We'll go to Utilities, then we're going to go to Rotate. Okay, when we go to Rotate, you have two types of rotate options. You have Rotate and 3D Rotate. 3D Rotate allows you to pick an axis of rotation. Regular Rotate allows you to rotate around your X, Y, or Z axis here. All right, what I'm going to do is I'm going to window pick this geometry. Okay, from here, I want to rotate it minus 180 degrees. Nope, let me see here. What do I want to do here? I want this to go minus 90 degrees to get it laying down flat in the XY plane. And then I want to rotate it 180 degrees in Z. So that way I have it facing this direction. Okay, I'll choose OK and cancel. All right, so what I've done at this point is I've just rotated the part. So if I'm in a top view, I'm looking down on the part. If I'm in a front view, I'm looking at the front view of the part, and a side view of the part. All right. Now, a question. Do you guys think it matters whether the part is located in Z or not? You can see this is the world coordinate system, and you can see the part is located in positive Z. Do you think that matters? Go ahead. Tell me whether you think that matters or not. Yes, it matters, Travis says. Okay. Some of you may say it does. I like to zero Z top at 0. No, yes and no. Still learning how to use CAD. All right, couple of different responses there. When it comes to machining, it really doesn't matter where the part is located, because when you run the stock wizard, you align the stock to the part, so it doesn't matter so much. But again, just to make it easier to edit, a lot of times you may want the top of the part to be at the top of world 0. John says you can define a UCS anywhere, a user coordinate system anywhere. And he's exactly true. So what he's saying is exactly true. So it doesn't really matter, but it can be helpful when you're editing geometry and things like that. Travis says, personal preference, but I find it safer to have top at 0. Okay. Yeah, I mean, generally, one of the reasons why I would want to move the top of the part to 0 has to do with when you're creating wireframe geometry. John's also talking about multiple UCSs. This part would definitely have more than one setup. We have a couple of different sides here, so sometimes it helps to have the part geometry located, at Z0. Now, we could translate this down, but one of the things that I want to talk about, one of my first topics here is after we rotate to a top view, is evaluate or measure. Okay, so we can go to evaluate here, and this will give us all of our measurement tools. So this way, you can measure your geometry. So sometimes you'll have a part print, sometimes you may not have a part print. One of the things we may want to do is measure how tall this part is. Okay, so we go to evaluate, and then we could do a measure 1, for instance, and we could just click on this top edge here, and then we'll have our measure entity window. Depending on what user profile, I use the After Dark profile. But depending on which profile you have loaded or how you've customized your screen, you may have the measure entity window here, it may be down here. You can go in and customize where it is. I like it right in this location here. By clicking and measuring on this one line, it's going to tell me that I'm at 2.3622. So if I want to move the part down now, I can go to Utilities, I can go to Translate. I'm going to window pick all of my geometry, and I'm just going to do a delta amount. So I'll say minus 2.3622. I'll say OK, and then cancel. All right, so I've moved the part down so the top of it is at Z0. Okay, all right. So again, to find out how tall it was, I went to evaluate, measure. Now, if you're, how many, so a quick question, how many of you guys are version 31 is your first version? If version 31 is your first version of BobCAD, just say, yes, this is my first version of BobCAD. And then that's me. Okay, Nicholas. All right, so we got one in here. Now, how many of you, Mark said yes as well. So how many of you, is this your second or maybe third version? Okay, so we got a couple people that it's their first version. You have a couple of people that it's multiple versions. Okay, if you are new to BobCAD, all right, you can go to measure 1, measure 2, okay, and you can measure right off the surface or solid. Okay, if you're new to BobCAD, hey, that's not a big deal. If you've upgraded from a previous version like Ron, who started in version 26, a lot of times in order to measure, we had to convert to wireframe. Okay, so you don't need to do that now. You can just measure right off the model, and we can do measure 1, and we can even pick up the radius size here. We can pick on the edge of this hole here, and you can see how we're able to measure that as well. Okay, so just a little tip there, but all right, so we measured the part. We orientated the part. Another thing that we may want to do, depending on what process we're going to work on, and this is the last topic really for CAD guys for today, is just you may want to convert the surface edges to wireframe. How do I measure points? Well, John, if you just go measure and you click on an endpoint here, you're going to measure that point. But what if you want to define the center of this circle here? You can see when I move my mouse over it, it doesn't find the center of the circle, right? So this is one of the reasons why you may want to convert to wireframe, okay, which is the lead-in. That's my next topic is, okay, we measured off the model directly. Now we may want to convert to wireframe, and we may use that for boundaries. We may use it for measurements, okay? As always, whenever I am creating wireframe and I have a solid model, I will create a new layer and make that layer active. Now I'm going to use the new use layer attributes because usually I like my wireframe and my solids to be different colors. So I'm going to just set this to like a gray, and then there we go. So I have the solid on one layer and nothing on this other layer here. Now from here, what I'm going to do is I'm going to create 2D geometry from the surface. Okay, so if you guys have been using BobCAD for a while, you know how to do this. You're going to find it under Create 2D. All right, it used to be, I think it was under Utilities in the past. Now it's under Create 2D. We're going to go to Extract Edges. We can do it from solid, or we can do it from single. So we're going to do Extract Edges here. All right, we're going to project to Z0. I just want to make sure that it's flat in the XY plane. So I'll do project to Z0. I'll pick on this surface here. I'll choose OK. I'll hit cancel. And what that's done is created the wireframe for that face there. All right. So if I hide the solid, you can see I now have the wireframe. Okay. John says, how do I measure points? Well, I don't have any points on the screen here. So I'm going to do a point. We're going to do a point arc center. So I'll put a couple points on the screen. All right. If you want to measure that point, you could do evaluate, measure, and you can click on that point and it will give you the XY position for that point. Okay, so that's one way to measure points. Now, the other thing is, because we have wireframe now, we get a few more options when we use measure 1. So if I go measure 1 and I move over that wireframe, you'll see all the snap points are displayed, and then I could pick the one just in the center, and that way I can measure just that point. All right. What is the difference between measure 1 and measure 2, John? Measure 1 is for measuring one entity at a time. Measure 2 is for measuring two entities. So I would measure between there and here, and it will give me some values. Or I could measure between here, and it would give us some values. Okay. So measure 1 is for a single entity. Measure 2 is for measuring between two entities. Okay. All right. So okay, to kind of back up real quick, we created it, or we imported our solid, we rotated it, we moved it down to the top of Z. We've created a new layer. We created some wireframe, and we've done some measurements. We've used measure 1 and measure 2 to get an idea of what's going on. The other thing we can do is use the measure auto or evaluate auto. This is a dimensioning tool. With this dimensioning tool, you can click on any of the entities. Now, here's the thing. I've noticed it's a little sticky with this, like the placement of the text. So what I do is I'll click on the line, I'll move it where I want it to be, spacebar, and then it locks it in, okay? So I could come in here and start measuring, you know, our whole locations, or I could figure out some angles or whatever it is to figure out what's going on here. But in this example, you know, we have measure 1, measure 2 off of single entities or multiple entities, and then the other one is auto in order to start dimensioning or pulling dimensions off the part. Now, let's see, Mark had a question. Why did the slot show up in the wireframe? The reason why the slot showed up in the wireframe is because when I created the wireframe, I selected this space here, okay? So let's do this. I'll turn this off. I'm going to do select, I'm going to window pick everything, delete, okay? I'll do it again. So we'll do create 2D, extract edges, and then this is the face that I've selected. So you can see the slot showed up because that's when you create wireframe from a surface, it's based off the surface that you selected. So hopefully that makes sense for you, okay? All right, so again, we created some wireframe. I'm gonna, the reason why I created some wireframe really is just 1, to show how it's done, and 2, to show that when you're working off the wireframe and you're evaluating, you get a couple of more options. You get more snap points using the auto function. You can come in here and just really just start pulling some dimensions so you can get some ideas of, you know, maybe some tooling. You may or may not have a print for the job. So being able to pull some dimensions is really kind of a common thing that you'll do. All right. If there's any questions about that, go ahead and let me know. Otherwise, we're going to move on. All right. So we got our part model here. We have it orientated. We created some wireframe. We've done some measurements. Okay. Now we're ready to get into the machining side of things. Okay. This part here would have multiple setups. All right. So I'm going to go through how to create some additional setups. The other thing is, you know, how you hold the part and what order you cut it in. I mean, that's really going to depend on you and how you want to do that. So I'm not going to focus too much on, you know, how I'm going to move the part from one op to another op, but more so really just focus on some of the standard machining cycles that we would use here. All right. So I'm going to get into the CAM tab here. From the CAM tab, I'm used to going down to this tab down here at the bottom. If you're an upgraded user to V31, you may want to start using the CAM tab at the top and start new job. Okay, so you can go either way from down here at the bottom, or you can go to the CAM tab, new job. All right, before I go any further, there's a, you know, they really brought a lot of the options of the software up to this CAM tab. Your current settings, your cutting conditions, your default machining strategy format, your tool library, your holder library, your adapter, your thread library, your material library. It's all brought up to the top here, so it's really easy to access, okay? Again, we're going to create a new job. You know, this is going to be a milling job. It's 2D milling, so we pick a milling job, we pick our machine, we're going to run our stock wizard, okay? So the milling job determines the type of tool path you'll have access to, so this would be milling tool path. The machine is your machine configuration, like a 3-axis machine or a 4-axis machine. In this case, or a 5-axis machine, right? In this case, it's a 3-axis machine. We're going to go ahead and run the stock wizard. The workpiece, usually I skip this step, but the workpiece, you could select your part model as your workpiece, okay? The workpiece is an option that you can display or not display in simulation. And there's a couple of ways that you can do that, but I'm just going to skip it like I normally do. All right. One of the things that is different from V31 30 and earlier and the V31 is when you change your stock type. In the past, I believe it auto updated. Now you have to hit calculate stock in order for it to update. Okay, guys? So, if I choose rectangular here, what I'm going to have to do is hit calculate stock in order for that rectangular stock to show up. Now, what it's doing here is it's looking at the minimum, maximum of the part geometry, and it's drawing a box out. Travis had a question. So do we draw stock? If we draw stock, we use the previous page you skipped to show it in simulation. No, Travis. The previous page, this one here is for your workpiece, not your stock. So if you want to select the stock, you would have to, if you want to select your part model as your workpiece, your part model is your workpiece. And I'll get into this a little bit more when we get into simulation. But when you go to simulation, solid models that are visible on the screen become your workpiece, okay? And it's an option in simulation, which I'll show you, okay? If you select your workpiece, I believe the way that it works is whatever you've selected will be passed to simulation versus all of the geometry that could be visible on your screen. So we'll go through that in just a moment. Let's see here. Brian has a question. In version 30, if you change the stock, it was, he had difficulty if you wanted to change it to something else. Yes. Again, what we're seeing here is under the stock types. If you choose a different stock type, in order for it to update, you have to click calculate stock. Okay. In this case, we're going to do rectangular stock. We're going to choose calculate stock. I'm not going to add any additional material on the outside because it's not such a big deal to me in this example, but we could, define stock or extra stock on the bottom, which is fine. Okay. Randy had a question, kind of like machining a casting. If you're machining a casting, you could you would use a different type of stock. There's 1, 2, 3, 4, 5, 6 types of stock here. If I was starting from a casting and I wanted to use the casting shape as a stock boundary, then I would probably use solid or STL, one of these two options as my stock, and then I would select it. Okay. But let's not get sidetracked here. We have our stock set at rectangular. We click calculate stock. We could add offsets here to add additional stock. I'm not concerned with that right at this time. Really, our next step here is to set our 0 position, okay, or our origin, as we call it, coordinate system, setup orientation, coordinate system, origin. This origin that we're going to pick here, this is your 0, your work offset, your touch off position. The position we pick here has to match the position we set up on the machine. Now, by default, it's picking up the world coordinate system. In my example, I'm just going to choose top center. Depending on your setup and your equipment and your fixturing, it could be anywhere. It just needs to match. This position needs to match where it might be at the machine. Now, the other thing I'm going to do here, because I'm going to end up simulating this, is I'm going to go to this work offset here, and I'm going to add a value to it. I'm just going to make it 5. This is because I have machine simulation. This will move the part up off the table. Otherwise, it's going to show that the part is in the table. So I'm just going to move it up, which is fine. And then I'll choose OK. All right. So what this has done at this point is it's set up a job. Let me go to my stock. I usually ghost this out a little bit. So I'm going to right click on my stock and go to transparency. And I'm going to turn this down a little bit so we can see, this is the stock geometry that we have set up. All right. We have a milling job. That job is connected to a machine. That machine is connected to a post processor. One of the things that you're going to want to do is you're going to want to select your post. If you right click and choose edit, you can choose a directory for where that post processor would be located. All right. For today's lesson, it's really about toolpaths, so I'm not going to spend too much time on that. If you have questions about your post or which post to select, you can always email support@bobcad.com, and they'll help you out. All right, so we have our job and we have our machine set up. One of the things that you'll notice is that there are two different coordinate systems. There's one over here and there's one here. This coordinate system is the world coordinate system, or the 0 for the drawing. This coordinate system here is our machine setup location, or our work offset, or our origin for our toolpath. Okay, so these are the two coordinate systems. Now, what I'll generally do is I'll go to my settings part, and I can toggle on and off the world coordinate system and the axis display. And I'll generally turn that off, so that way it doesn't really matter where the 0 is for the drawing. I can just focus on where the 0 is for the job. Okay, so my 0 for the job is going to be top center here. Now, what do we want to do? We want to get into some toolpaths, okay? So first off, if there's any questions about what I've gone through there, and there's no questions are a bad question. I know we have different levels of users here. There's some newer guys in here. I know there's some more experienced guys in here. But if there's any questions about rotating, creating wireframe, measuring, setting up the job, just go ahead and ask those questions now. I may not answer them right now, but we'll email you, or if there's something that's really an outlier, we'll go into more detail on that question. Okay, guys? All right. So if you have any questions about how we got to where we're at now, go ahead and fire away. Otherwise, we're going to keep moving forward. So we want to talk about facing. Okay, so facing is a really common type routine. A lot of times we're facing down our part. So we're going to right click on our machine setup here, and we can go to our different machining cycles. If you're a version 30 or earlier user that upgraded to V31, this has generally been our workflow, is we right click on our machine setup, and then we'll go down to our machining feature. Okay, in the V31, you can actually go to this section right here. These icons represent the different machining features that you can create. There's a little arrow down and arrow up, so you can pick through to, which ones you may want to select. This first one here would be the mill 2-axis routine, so we can choose that option there. Okay. All right. By clicking that icon there, it will start the mill 2-axis wizard. Now, this wizard interface and workflow works the same as all the previous versions of BobCAD up to 22. Starting with 22, we went to this wizard style and this cam tree, so you're going to be able to see what's going on. And you're going to be able to use the same workflow that you've had in the past with the wizard with the most current version here. The first step would be selection. So, I'm just going to choose select geometry here, and I'm going to pick this face because that's what I want to face. Okay. I'm going to set my top of job to 0.1, and I'm going to set my depth to 0.1. Now, I don't really have any material. I haven't put any material on the face of the part here. So basically, I'm just telling it to cut to 0. But you could also have material on the top that you're facing down. If you've zeroed the top of the part, and it depends on how your setup is, but generally speaking, with your face cycle, a lot of times you're going to set it to where you're facing to 0, but that's kind of up to you. Either way, we've selected our face here. We tell it where we're going to start cutting. We tell it how deep we're going to go. We're going to choose OK. All right. We're going to come back to our machining strategy here, and we're going to choose face, and then we'll choose next. All right. From here, we'll go to our tool. I'm just going to jump ahead to our tool, and I'm just going to type in a tool size. Maybe it's a 3-inch face mill. Maybe it's a 2-inch face mill. It depends on what you're using. All right. Now, there is some speeds and feeds that are being calculated for me. This is based off the material that we're using, and it's also based off the tool that we're using. You can override this. You can just come in here and type in the surface footage and chip load that you want, or you can just type in, the speed, your RPM, and your feed rates that you're going to cut at. Okay, so really easy. You can just type in what you want there. For us, I'm actually going to just compute the defaults at this point. And by computing the defaults, we're going to see some toolpath is on our screen. I'm going to come over to the face feature here. I'm going to right click on the operation, so this is the feature. This is the selected geometry. This is the operation. I'm going to right click on the operation and I'm going to choose backplot. Choosing backplot will display the tool. I can click through and see where the tool is going to go and what direction it's going to cut in. Now, if we look at this on the first pass here, you can see the center of the tool is right on the center of the geometry and like on the center of the cut, and that's probably not the best scenario. Right now we have it cutting in 2 directions, so let's go and look at some of our settings here. So we'll close this. We're going to come back to our feature, right click, edit. Okay, we can go to patterns, and these are the different patterns that we can use for facing. So we have zigzag, which is bidirectional, zig, which is single direction, and then we also have an adaptive, which is similar to a spiral where it will work its way in. Mill multi-axis is that 5-axis stuff. It's not accessible on my standard V31. Yes, John, mill multi-axis, you'll gain access to that as a mill premium. Excuse me, a mill premium user or a 4 Pro, 5 standard, or 5 Pro will get access to those toolpaths. All right. Let me see here. John, is it recommended workflow to type in the tool data on the fly or set up tools in the tool crib? Thomas, I do recommend, here I'm just typing it in on the fly, and what it will do is if this tool size lives in your tool library, then it will call that tool. I do recommend that you set up a tool crib and you load a tool crib at the beginning of a job. I think that is very helpful, but it really just depends on your shop, and what kind of equipment that you're using. So it could work either way, but I do generally recommend setting up a tool crib and loading a tool crib before you start programming. All right. All right. So we have our different patterns here. So we were doing it as a zigzag. We'll go to a zig. We'll recompute to update the tool path. And then we'll see that it's going to come over here and cut in a single direction. So it takes a pass, rapids back, takes a pass. All right. If we come over here, we can right click on the feature, choose edit. We can go to the patterns. This time we'll go to an adaptive and we'll recompute. This will take a second to calculate. And, once it's done, we'll get an adaptive type strategy where it works from the outside in. Okay. So you have bidirectional, single direction, and adaptive for your facing cycles. Now, my system's running a little bit slow. I feel like I have some monitoring software on my computer that's hindering its performance. But generally this will calculate pretty quickly here. All right. On the adaptive routine, you can see how it's going to work its way in from the outside, and it kind of comes across, then is facing this geometry here. Okay. I would generally, because the geometry that I selected is this irregular shape, if I was going to do more of an adaptive style, what I would have done is selected a boundary of the entire part versus just some of this geometry here. And I could do that by creating a sketch, which would work. Now, all right, so I'm going to go back here and we'll go to patterns. So you have bidirectional, single direction, and adaptive. Okay, we're going to go to bidirectional again and we'll recompute. And you can see we get the 2 passes here. So we get 1 pass here and 1 pass there. I really don't want 50% of the tool on and off. So what I'm going to do is I'm going to adjust that first pass. Again, I'll edit this feature. I'm going to go to patterns here. And then this has a first cut offset. This allows you to move that first pass over a little bit by any value that you put. We can recompute. And then what that will do is offset that geometry so that it doesn't start 50%. Okay, so you can see even selecting this irregular shape here, I'm able to come in here and to face this part down, no problem. If you wanted to create a different boundary instead of that face, what you could do is, let me go to a different color here. What I could do here is just sketch a rectangle. You could come up and say, a 2-point rectangle, and we'll say starting from here and going to there. All right, so that gives me a boundary. Instead of selecting that face, we could just use this rectangle. The reason why I bring this up is sometimes you may want just the tool to run down the center of the job. And the easiest way to do that, really, you could just do a profile routine. You could just draw a center line that you wanted the tool to follow, and then you could do a profile routine. Okay? All right. So there are a couple of other settings here under facing. You have on the workpiece and off the workpiece. Okay, if you have on the workpiece, then the tool will stay on the workpiece. If you have off the workpiece, it goes off the workpiece. There's this distance percentage of tool. Right now I have it 0, so I could say 50% and recompute, and that will show the tool probably how you might have expected it, where center of the tool. This is for on the workpiece. When you have it set to off the workpiece, okay, so right now I have it on the workpiece, 50% of the cutter. If I say 0, it will go off the workpiece, really. And then if I say 25%, 25% of the cutter will be on the workpiece. All right. Same thing with off. This is the distance. So it's pretty straightforward. I recommend that you kind of go through it a couple of times. If you adjust some of the settings and see the result. And, that's really a good way to kind of get familiar with it here. All right. Okay. So we'll recompute here. We get our facing cycle. Any questions about the facing? Go ahead and fire away. Otherwise, we're going to move to a different area of the part. But before I do that, again, just as a recap here, you could select the face, the top surface, or you could create a boundary. Either way, you can use that to drive your toolpath. All right, very good. Now, so we did our face cycle. Let's look at something else. Now, generally what I'm going to do here is I'm going to blank. So I'll right click on this feature and I'll blank it out. That's going to hide the toolpath. I can click back on our setup here and we can look at some of the other options that we may use. Okay, so the next thing I'm going to go to is drilling holes. Give me just a second here, guys. All right, sorry about that, guys. Okay, so the next thing I want to look at is drilling. So I want to get into some drilling. Okay, so we're going to right click here. We're going to go drill hole. All right. Choosing drill hole, we can choose select geometry. From select geometry, this is going to start the hole geometry picking options. There's a couple of types of hole picking. You have standard, you have multi-axis, you have cross drilling. Okay, so this depends on whether you're doing, whether you're using a 4th axis or you have a 5th axis or just a 3-axis. Because this is 2D machining that we're talking about today, we're going to just do a standard drill cycle. Now, as far as the geometry you guys can select, there's a lot of different types of geometry you could select. You could select wireframe, you could select surface edges, you could select points. And depending on what geometry you select, the software can do different things with it. It could read the size, where it starts, where it ends, and that kind of stuff. So the first thing I'm going to do here is I'm just going to select these tubes here for these smaller holes. Okay. So those are the holes that I want to drill. So I select them. We'll choose OK. All right. It's going to read the diameter. It's going to read the depth. I can tell it whether it's a through hole or not. I'm going to choose next. Okay. In this section here, it's talking about where it's going to start cutting and where it's going to end cutting. If we have holes that are starting and stopping at different hole locations, they'll be listed here in the different groups. So you could program holes that start and stop at different locations at the same time. Okay. We're going to go to machining strategy here. We're going to go to hole cycle. That way we're going to spot and then drill. And then I'm just going to compute the defaults. All right, so you can see we drilled some holes there. If we want to grab some additional holes, we'll just repeat the process. We'll do drill hole, select geometry, we'll select on this face, we'll select on this face, we'll choose OK, and then we'll compute. All right, so, I forgot to add the features, excuse me. machining strategy hole, and then I'll just compute the defaults. All right, so we drilled 2 different size holes there. You know, this one over here I want to address because you can see that it doesn't start at the same Z height, but we would still need to drill it from there. We'd probably drill the hole first and then do the counter bore. All right, so how do we adjust that? We're going to do drill hole. All right, we're going to select geometry. We're going to pick the cylindrical face. We'll choose OK. All right, we'll leave the default settings here. We'll go to our whole group. All right, we're going to say that this actually is going to start at 0. And then we'll just add, we'll make it 45 over here for our punch through. And then we'll compute, we'll go to machining strategy, hole, and then compute. And then that way we're able to drill that hole starting from 0 and then working down from there. Okay, all right. Is there any questions about drilling? Any questions that you guys have at all? What if you have, let's see here. What if you only have a 2D drawing? How do you drill? You know, that's a really great question. One of the things that I love about the BobCAD system is you can work with wireframe or you can work with surfaces and solids. If I go to my wireframe layer here, maybe you got a DXF file from a customer, you know, you can go through and just select the wireframe geometry. The only difference with that, Paul, is that the wireframe geometry doesn't read the depth in Z. So you just have to enter the depth in Z. It will default to 0.5. Okay, so it'll default to a 1/2 inch depth, I believe, and then you can override that and tell it how deep you want to go. Thomas had a question. What does BobCAD do with the information of blind and through hole type? Okay, that's a good question. If you're in here, you'll see through hole and blind hole. Blind hole, it basically doesn't do anything. It will drill to the depth that you tell it, plus the tip comp. It will do drill tip comp. Through hole, what it will do is it will punch through. It will go a little bit deeper. And if I cancel here, and I go to, let's see where this is. Let's go to not current settings. Let's go to CAM. Let's go to cutting conditions. Okay, so cancel. So if we're in the CAM tab and we go to cutting conditions here, what you're going to see is some different options here. This has to do with the different drill cycles. And then let's see, PEC retract amount, add to depth for blind tapped holes. Let's see, PEC increment, and then length through cut. So if you're drilling, this is going to add 50 thou for your through holes here. These settings are the default settings that affect some of the different drill cycles that you have. Okay, so if it's a blind hole, it will go to the depth that you tell it plus the tip angle. If it is a through hole, then there's a punch through amount that you can adjust. Hopefully that makes sense for you there, Thomas. And hopefully, Paul, you're clear on working with wireframe for drilling. Same process, okay? All right, so we've created some holes here now. All right, so drilling, you could drill, you could have them start and stop at different sizes. You can load in, you know, a spot drill, a drill. You could do tapping, counter boring, all that kind of stuff. No big deal. All right. The next thing I want to look at here has to do with, you know, this counter bore over here. What I want to do with this counter bore is I actually want to pocket that area out. So we're going to come in and look at our pocket cycles. We're going to do insert mill to axis. We're going to do select geometry. We're going to select the edge of the arc here. Okay, we're going to pick how deep we want it to go, and then we'll choose OK. All right, from this strategy here, we're going to go to pocketing. I'm going to remove the finish tool, so we have a pocket cycle. I'll go to my tool size. I'm just going to put a 3/8 in here. All right, for my pattern, what I'm going to do is I'm going to go to use spiral for circular pockets. Okay, so if you select a circular pocket, you can use a spiral for circular pockets. I'm just going to compute this, and then what we'll see is we're going to just get a spiral path to come in here and to clean up that counterbore. That's a really great way to come in and clean up counterbores. It'll start right in the center and then it'll work its way out. Very popular tool path for circular holes, okay? Another thing that I want to look at here, like these holes, this is like a 5906. I don't know whether if it's a metric one converted to inches, or I don't know if that's like a specialty tools hole size. I'm not really sure, but what you may end up doing with this is drilling it with like a 1/2 inch end mill and then finishing it to size. Yes, Mark, we'll get into spring passes in just a second. Okay, so what you may do here is you may drill this to size, but then you may either ream it or you may circular interpolate it. And that's the next one I want to look at here. We're going to go to Insert Mill to Axis. We're going to go to Select Geometry. I'm going to select this hole here and this hole there. I'm just picking the top of it. I'll pick the bottom. So I'll say that's how deep I want it to go. I'm going to add a punch through of 100 thou. All right, so that's how that's the geometry that I want to run, and then how deep I want it to go. In this case, I'm going to do a profile rough routine. Okay. Tool size, I'm just going to put an 1/8 inch end mill, something that I know will fit in there. And then our pattern here, what I'm going to do is instead of a standard, I'm going to do contour ramping. And contour ramping you can use for slots, you can use it for holes, you can use it for roughing outside shapes. Contour ramping will ramp down to the bottom. I'm going to go to my parameters here. I'm going to 0 that, and then I'm going to set the depth per pass. So I'm just going to say 100 thou, and then I will compute this. All right, so what that's going to do for these holes here is it's going to helical interpolate. That's okay, that's a little silly there. Let me jump up my tool size. Okay, so I'm looking at this. I have an 1/8 inch tool to come in here and to helix these holes out, right? Which probably doesn't make sense. So I'm going to jump up in tool size. So I'm going to edit this. I'm just going to click on my tool, and then we'll make this a 1/4 inch, and then I'll recompute. So what that will do is just increase the tool size. This one here, I'm going to backplot again, and you'll see that this circular interpolates, gets down to the bottom, comes back out, works over to the other side, and will continue down to the bottom. You know, you can see how there's the punch through, and then once it's done, it will come back out. Okay, so we did, for this one here, we used a spiral pocket in order to do our counterbore. This one here, we're doing some helical milling in order to clean up these circles here, okay, or these holes. All right, the next thing I want to look at is, you know, these sections over here. I got about 10 minutes left. You know, a lot to cover, trying to cover at one time, but in this section here, you know, I want to use this same type of routine, this helical milling, but instead of for the holes, I want to use it for these slots over here. Okay, so I could right click and, you know, create a new feature. But what I'm going to do instead is I'm just going to take this feature and I'm going to copy, and then I'll take this feature and I'm going to paste. All right, so by copy and paste, I can use the same tool and settings that I have. So I'm going to say, do I want to use the depth values? Do I want to use the same depth values? I'm going to say, no, I don't want to use the same depth values. I'll come over to my geometry. I'm going to choose reselect. Okay. And from here, I'm actually clicking on the edges of the surface. You can right click as well and choose loop or tangency, but, or constancy, loop or constancy, but I'm just going to pick the edges. That's what I want to cut. Where do I want to start cutting? I want to start cutting at the top. Where do I want to go? I want to go down to the bottom. And like I said, I'll just add a punch through amount here to make sure that it goes through, and we'll choose OK. All right. From here, I'm just going to recompute my toolpath. And then what we're going to see is a slotting type routine where the tool will work back and forth along this edge in order to create that slot there. Okay, so that is coming through machining that side. Again, this is using contour ramping for a profile. So you have a profile and you can contour ramp. A great option. Now in this section here, I have kind of this open type pocket. I guess there's a couple of different ways that we could approach that. Again, let's just blank all our toolpath out. I'm going to turn down the stock transparency. Okay, so I can see it ghosted, but it's not all up in my face here. All right. What I want to do, there's a couple of ways to do this open area here. We could do this as a profile, or we could do it as a pocket. Let's go ahead and do it as a profile. So we'll do Insert to Axis, select Geometry. What I'm going to do here is I'm going to right click on this edge, and instead of clicking around the edge like I did the last time, I'm going to choose Constant Z. That's going to select all the way around, but then what I want to do is unselect this edge here because I don't want to profile that section. The next thing I'm going to do is say where I want to start cutting, which is 0, and then the depth, how deep I want to go. I'm just going to pick off this edge, and then I'll choose OK. All right. Now, the strategy that I'm going to use is going to be a profile. I'm just going to look at the roughing right now. Okay. Tool size, I don't know. Let's try a 1/2 inch here. Okay. We're going to do a standard, and I'm going to compute the defaults. All right. So with this one here, what we're going to see is the tool is going to come in, and then it's going to go out. All right. So it comes in and goes out. Now you can see how it's starting right on the edge of the part. And we probably wouldn't want it to start right on the edge of the part. So what are we going to do? Well, we're going to add a lead to it. We're going to right click on our feature here and choose Edit. Okay. We're going to go to Leads. We're going to say Parallel Lead. We'll make it, I don't know, 300. And then Compute. And then we can see we've added some leads here. Now you can see that the tool is going to work its way across. You know, just cleaning up this this edge here. If we wanted to take more than one pass, we can come in here under patterns, and we could do something like side roughing. We could say, you know, maybe there's a 1/4 inch of stock and take it in 2 passes. And then what that will do is create some additional passes for us here. All right. So this way we can come in and clean that area out. This is one way of doing it with a profile. You know, we could also do this with an open pocket as well. How does that work? If I'm going to do the open pocket, what I'm going to do is convert this to wireframe. All right. So I'll create another layer here. We'll just make this a different color. All right. We're going to go to create 2D, extract edges. I'm going to do project to Z0. I'll just pick this face, choose OK, cancel. I'll turn everything else off. I'll go to a top view. All right. I don't want to see the other toolpath in my way. So what I'm going to do is blank it out. So I'll go to the cam tree, and I'm going to just blank that toolpath out. As far as the inside shape geometry, I'm just going to select it and delete it. And then this line here, what I need to do is I need to turn this line into a dotted line for an open pocket. What about cutter comp? Okay, so we're getting to that. We're getting to spring passes, and we're getting to cutter comp here. Okay, Mark and Bob. All right. So first we have a closed shape, and for pockets we use closed shape geometry for pockets, right? So we're gonna come to here. We're gonna do Insert Mill to Axis. We're gonna select our geometry. We'll window pick everything. We'll choose OK. We'll go to Strategy, Pocketing. I'm gonna get rid of the Finish Pass. Okay. We're going to just do an offset out pocket, and then we'll compute. All right. So in this case, what's happening here, because we have it set to a pocket, is the tool is going to stay inside of that boundary. Okay. So it's going to stay inside of the boundary. See how it didn't go past this edge here? Because when you're using a pocket, the tool stays inside of the pocket. So what do we want to do in order to get the tool to go outside of this edge here is we want to make it an open pocket. All right, so a couple of things. Let me edit this feature. I'm going to do pick bottom because it went to the default depth. So I'll say pick bottom. Okay. I'll recompute here. You can see the tool path that's on there. All right. We actually want the tool to go outside of this edge here. So how do we do that? We're going to we'll go to selection mode. Okay. And we're going to select this line here. All right. And then once we have it selected, we're going to right click, modify attributes, line style, and then we're going to turn it to a dotted line. All right, so this is the reason why we want to use open pocketing here. We want to use open pocketing to have the tool come in from the outside, and by selecting this line and turning it to a dotted line, we're telling the software that is the open area for the tool to go through. Okay, so we'll reselect the geometry, choose OK, we'll recompute, and it's still cutting inside of there. Why is that? Because we have to pick a strategy that supports open pocketing. So we'll right click on the feature again and choose edit. All right, we're going to go to patterns here, and the standard pocket types, parallel, offset in, offset out, do not support open pocketing. All right, the advanced pocket types, these do support open pocketing. So we'll do, if you're going to do like a tricordial machining, it would be an adaptive routine. So we can choose adaptive and compute that. And then what that will do is come in there with the tricordial style cutting to come in and do that pocket. If we don't want to do an adaptive routine, there's really not that much material here. We may do like an offset in type routine, and we'll recompute that. And then that will work its way in, which essentially ended up doing a profile here. We could also do, if we edit this, we could do, maybe like an offset out type routine, and that will come in and work its way out. Now, if I adjust the step over, right now I'm at 50%, so it's not like coming in and doing another pass here. So if we edit this and, if I drop down my step over to 25%, we'll see, some more passes on the inside. Okay. Now, all right. So let's say we want to finish this now. So we roughed it out and then we want to finish. We're going to come back to our feature here, and then we're going to add a profile finish. Okay. I'm going to go to the leads. I'm going to add a parallel lead, and I'll recompute. So here's the thing. The pocket routine isn't going to post cutter comp, Bob. Okay. Pockets don't post cutter comp. Pockets will leave stock on the wall for finish, and your profiles, you can use cutter comp. So here's my pocket. I'm removing the bulk of the material, and I'm leaving stock on the wall for finish. And then I'll come back with my profile. And then with that profile, that's where I could use system comp and machine comp. System comp is when BobCAD offsets for half the cutter. Machine comp is where you can throw a G41 or G42 in there so you can dial in the wall. Okay, so the pocket cycle doesn't have any comp settings. The profile setting does have a comp setting, so you can use G41, G42. Okay. Now, let's see. Mark said, well, how do I add some spring passes? Well, we did one profile here, and you can see this profile is coming in and doing a finish pass on the wall. A spring pass is just another pass at the same location. So the way that I do that is I just right click on the profile finish. I do copy, right click, paste. So I've added another pass, and then I just right click and compute, and that will give me 2 spring passes, or you could do 3 or as many as you need. Okay. So hopefully that answers your question on that, Mark. And then Bob, hopefully that answers your question on cutter comp. Okay. Now it is the 2 o'clock mark here. So what I am going to do is I'm going to stop the recording on the webinar for now. I'm going to keep going for a little bit longer because there's some more topics that I want to get into. Another great reason to be here for the live webinars. And I know that you guys, some of you may need to get back to work. Some of you may need to, or some of you can spend time with me. So it's up to you guys. But again, these are our webinar Wednesdays. For supports, we have every Wednesday from now to the end of the year is the first schedule. I really appreciate everybody spending some time with us. These webinars are recorded and they will be hosted on the support page. And I look forward to seeing you guys in the next one. Thank you so much.